Hey there, and welcome. Have you ever hit a wall with one of those time and work math problems? You know the ones. They seem like total brain teasers, but I'll let you in on a little secret. They're actually just logic puzzles. And once you know the code, they're surprisingly simple. So today, we're going to crack that code together.
All right, let's jump right in with a classic. This is the kind of problem you see all the time. Now, your first gut reaction might be to just, average the days out. But nope, it's not quite that simple. To get to the real answer, we need to completely change how we think about the problem, away from the total time and toward daily progress. So before we can actually tackle that puzzle, we've got to build our foundation. The very first step is to get a grip on the simple core relationship between the effort you put in and the work that actually gets done. It's way more straightforward than you think. Believe it or not, every single one of these problems, no matter how complicated they look, just comes down to these three things. You've got the number of people doing the job, which we'll call men, you've got the time they spend on it, or days, and you have the task itself, the work. That's literally it. And here's the formula that ties them all together. The total amount of work done is just the number of workers multiplied by the number of days they work. A really easy way to think about it is in person days. So, if you have 10 people working for 2 days, that's 20 person days of work. Pretty simple, right? Just keep that idea in your back pocket. Okay, now we get to the real key. The secret to solving our puzzle isn't about the total time it takes at all. It's about how much work gets done each day. This idea is called efficiency, or work rate, and honestly, it changes everything.
So, this is the crucial mental shift you need to make. We've got to stop thinking about the total 10 days or 15 days. Instead, we need to ask a totally different question. What little piece, what fraction of the entire job gets finished in just one single day? This right here is where the magic happens.
And this is the big aha moment. It's so intuitive once you see it laid out like this. If worker A needs 10 days to finish the whole thing, it just means that every single day they're knocking out 1/10 of the total work. That 1/10? That's their daily work rate. That's their efficiency. Now check this out. This is another cool way to visualize the same idea. Instead of dealing with fractions, which can be a little annoying, we can just pretend the entire job is made up of, say, 30 units of work. So if worker A takes 10 days, they must be doing 3 of those units per day. And worker B, taking 15 days, does 2 units a day. It's the exact same concept, just using nice, clean, whole numbers. So let's put it all together and solve this thing. Worker A does 1/10 of the job per day. Worker B does 1/15. When they team up, we just add their daily efforts together. So 1/10 plus 1/15, that adds up to 1/6. This means together, they complete 1/6 of the job every single day. So how long does the whole job take? You got it, 6 days. See, not so scary after all.
Okay, that was great for a nice, simple case. But what about when things get more complex? With changing numbers of workers and different tasks? Well, for that, we have a master formula that's kind of like a Swiss Army knife for these problems. All right, let's take a look at this one. In the first scenario, we have 10 men cutting down 8 trees in 16 days. Okay. In the second scenario, we only have 6 men, but they need to cut down 10 trees. The big question is, how many days is that going to take them? Now, this looks pretty tricky, but we're about to see how one single formula just makes it all fall into place. And here it is. This formula basically says that the ratio of person days to the work done always stays the same. So for our 2 scenarios, men 1 times days 1 divided by work 1 has to equal men 2 times days 2 divided by work 2. So let's just plug in the numbers. For scenario 1, that's 10 men times 16 days divided by 8 trees. That's 160 over 8, which is 20. Now for scenario 2, it's 6 men times our unknown number of days, D2, divided by 10 trees. So we know that 20 has to equal 6 times D2 over 10. To solve for D2, we just do a little algebra. 20 times 10 is 200, then divide by 6, and we get 33.33. So it's going to take those 6 men about 33 1/3 days to cut down 10 trees. See how that formula keeps everything perfectly in balance?
I know all these formulas and numbers can feel like a lot to keep in your head. But honestly, it all boils down to 2 very simple, common-sense ideas about how work, well, works. If you can just remember these 2 things, you can reason your way through almost any of these problems. And here they are. It's this simple. First, the more people you throw at a job, the more work you'll get done in the same amount of time. Makes sense, right? We call that directly proportional.
And second, the more people you have, the less time it takes to finish the same job. That's an inverse relationship. That's it. Every single formula we've looked at today is just a fancy mathematical way of saying these two simple truths.
So we've definitely cracked the code on these standard time and work problems, but here's a little something to chew on. All of our math today assumed that everyone works at a steady, constant pace. But what happens if that's not true? How would you even begin to solve a problem where a team is learning on the job and actually getting faster every single day? Now that's the next level.